So here is our video on synthesis and decomposition reactions. It's the first one where we actually talk about the different types of chemical reactions. So some of this is going to be review for you, but we are going to go into these reactions in a lot more detail. So synthesis reactions occur when two or more substances combine to produce a more complex substance. So here's a general formula. A plus B gives you AB. And you can see my product. I always only have one product, and it's always a little bit more complex than what I started with. Okay, so that's one way that you can recognize a synthesis reaction. There are 4 different types of synthesis reaction, and here's where we get into the nitty-gritty details, so pay close attention to this. The first is the reaction of elements. So you can see in both of these examples, we start off with elements such as copper and oxygen, or iron and oxygen, and we make our more complex compound at the end. So copper 2 oxide, and this is iron 3 oxide, or ferric oxide. So in both of those cases, I'm starting off with nothing but elements, and I'm making something a little bit more complicated or complex. The second one is a reaction that produces a salt, and this most common salt that we're going to see is a carbonate. So you can see I made, in this case, calcium carbonate. I had two reactants that made one single product, so I know it's a synthesis reaction because I only have one thing on my product side. In this case, it's a carbonate, and you have to remember that a carbonate comes from the synthesis of a metal oxide. So a metal bonded to oxygen and carbon dioxide, always, okay? So if you see a metal oxide and carbon dioxide, you have to remember that it will make a carbonate. So you check your charges and crisscross, and you can figure out what your product is. 2 more types of synthesis reactions that produce an acid. So for example, this one here, SO3 plus H2O will give you H2SO4. Note, to produce an acid, here's the thing you've got to remember, you need a non-metal oxide reacting with water. So let's see if that makes any sense. Here's my non-metal oxide, my sulfur trioxide. So sulfur is a non-metal, it's bonded to oxygen. Okay, that makes it a non-metal oxide. When it reacts with water, it makes an acid, so I take my sulfuric acid here, okay? I basically just take my oxygen from my water and add it to my non-metal oxide, and I put my hydrogens in front, and I balance everything out, check your charges and crisscross, and I make my acid. The reaction that makes a base, example is here, so this is barium oxide and water makes barium hydroxide. So remember, a base is something that has a hydroxide ion in it. So here's the thing you've got to remember. Note, to make a base, in this case, you need a metal oxide. So for an acid, you needed a non-metal oxide. To make a base, you need a metal oxide. So which one is my metal oxide in this example here? It's the barium oxide. So barium is my metal, and it's bonded to oxygen. When you take those and react them with water, you make a base. Okay. So those are the 4 different types of synthesis reactions that you need to know about. The tricky part is going to come in when I only give you the reactants and you have to predict the products. So we'll talk more about that at the end of the video. All right. Second type of reaction is a decomposition reaction. Hopefully you remember from grade 10 that it's sort of like the reverse of a synthesis reaction. So you're going to see a lot of the same thing happening here, but just in sort of the opposite direction. So a compound gets broken down or decomposed to give 2 or more simpler substances. So to recognize a decomposition reaction, you only ever have one reactant. And then it breaks up into 2 or more products. It usually requires high energy or temperature or an electric current. And there are 5 different types of decomposition reactions. So the first is a decomposition that will produce an element. So here is mercury oxide, mercury 2 oxide I should say. If I add heat to that, it will decompose into straight up mercury and straight up oxygen, which are elements from the periodic table. So this is a very rare form of decomposition, but it does happen. And then I've got the decomposition of acids and bases. So if you have a look, I've given you an example of an acid, carbonic acid. If I add heat to that, I make my non-metal oxide and water, the exact opposite of my synthesis reaction. And then if I look at my decomposition of a base, here's calcium hydroxide. So remember, to make a base, I needed a metal hydroxide and water. So when I decompose a base, I get my metal oxide, and water as well. Move that out of the way. There we go. So you can start to see how these are the reverse of the synthesis reactions. Last two types of decomposition reactions, and this should say number 4 and number 5, is the decomposition of a carbonate. So I showed you the synthesis of a carbonate. It will always give you, for the decomposition of a carbonate, it always gives you a metal oxide and carbon dioxide. Now remember, when we decomposed a base, I got a metal oxide and water. Okay, so in this case, it's different than a base. I'm not making water in my products. I'm going to make carbon dioxide instead. And then the last one is a decomposition of a nitrate, and this will always give a metal nitrite, which is one less oxygen, and oxygen gas, O2. All right, so here's my metal nitrite, sodium nitrate, and I've got oxygen. So now the tricky part is going to be predicting the products of these. It's easy to kind of identify them if you have the whole reaction, but when you don't have the whole reaction, what ends up happening? So let's look at something like this. So if I give you, say, we'll start with something easy. So MgOH2, and you have to predict the products of that. So if you want to try and do that on your own, you can. Right now, if you want to pause the video, I'm going to do the answer right away. So this is a base, so what you have to remember is a base will decompose into a metal oxide and water. So I'm going to make my metal oxide. Here's my metal, magnesium. So magnesium bond into oxygen. Check your charges and crisscross to make sure you get the right formula, and water. So boom, there is my product. Another one is the decomposition, or you know what, let's do a synthesis reaction here. So if I give you something like this, what does that make? Now if you look at this, it doesn't look like we're going to make an acid, it doesn't look like we're going to be able to make a carbonate or anything like that. So this is an example of those ones where we synthesize something from the elements. So we will end up making AlBr3. And again, you check your charges and crisscross. That's how I got that 3 as a subscript. And then you should go back and balance everything out. All right, so if you have any other questions about that, we'll take them up in class and we'll do lots more worksheets on this as well.